Hi everyone, I'm Cheryl. In this problem, we're going to be graphing a sine curve. But before we get started on y equals minus sine of 2 pi x over 3, which is the problem at hand, I want to talk a little bit about what just a basic sine curve looks like. Right? A sine curve is this wave, and it continues forever in both directions. There are several key features that you want to consider when looking at a sine curve. One key feature is the maximum. On a basic sine curve, it never goes any higher than 1. The minimum, which never goes any lower than -1. Another thing you might want to consider are these intercepts that are happening at 0, pi, and 2 pi. Notice that all the key points, the intercepts, the minimums, and the maximums, all happen at evenly spaced intervals. Okay, well, how does that help me with a more complicated sine curve? Well, I'm still going to be looking for those key features. So first of all, let's talk about the amplitude of my new graph. The way we find the amplitude in our more complicated sine curve is to look at the a value, or the constant that's in front of my sine. So in this problem, we'll be looking at the absolute value of a, and a happens to be a -1. So we have an amplitude of 1, which means that this sine curve also bounces between +1 and -1. So I'm going to mark that on my axes. The next thing I'm going to determine is whether or not this graph is reflected. The fact that my a value was a -1 means the graph is reflected across the x-axis. So I'm going to mark down that this is reflected, and I will use that later on. The next thing I want to consider is the period. In a normal sine curve, I'm able to fit one cycle in 2 pi units. In this particular curve, the period will be altered because of the constant that goes along with the x. To calculate the period, we're going to take 2 pi and divide it by what we call the b term. The b term is the 2 pi divided by 3. So let's do that calculation as well. 2 pi divided by 2 pi over 3. Now that's a compound fraction, so we need to do a little work. This is going to be the same thing as 2 pi over 1 times 3 all over 2 pi. The 2 pi's cancel, and I'm left with a period of 3. So I'm going to be able to fit a complete cycle of my sine curve in 3 units. So let me mark that down as well. Here's 1, 2, 3 units. Okay, now the next thing I want to do is figure out my spacing. What's my spacing between all of these key points, the minimums, maximums, and intercepts? Well, if you think about it, there are 5 key points. 3 intercepts, 1 minimum, and 1 maximum. If you have 5 key points, there are 1, 2, 3, 4 intervals between them. So I'm going to take my period and divide it by 4 to get the spacing. So the spacing is going to be 3 over 4. And I'm just going to mark down that that's my spacing. Okay. The last thing I need to consider is where's the location of that first key point? In a standard sine curve, it's at 0. But that may not be the case in my problem. What we're going to do is we're going to, again, take that 2 pi x divided by 3, and we're going to set it equal to 0. Because 0 is where I typically start. So I'm going to mark this as 2 pi x divided by 3 equals 0. And I'm going to solve it for x. This is actually a pretty easy equation to solve. We just have to multiply both sides by 3 divided by 2 pi, and x is going to equal 0. So that's my starting point. All right, so let's see if I can transfer all this information to my graph. I'm going to start with my first key point at 0. To get to my next key point, I have to move 3/4 of a unit. So that's going to put me right about here. And that's 3/4. I'm going to move another 3/4 to get to my next key point. That's going to put me at 1 1/2. Okay, so that's 3/2. I'll move another 3/4 to get to my next key point. So that's going to put me at 9/4. And one more time, another 3/4 to get to my next key point. And guess what? That takes me right to 3. And I know that I should be able to fit an entire cycle in between 0 and 3. Okay, so I've got my key points marked down. Now I have to put in my minimums, maximums, and intercepts. Because this is a sine curve, my first key point will be an intercept. My next key point, typically it's a maximum, but don't forget, my graph is reflected. So that means that my next key point will be a minimum. And after that, it's pretty easy because the next key point will be an intercept, the next one will be a maximum, and the last one, an intercept. I already know basically what a sine curve looks like, and so I just have to fill in that wave. And don't forget that a sine curve continues to wave like that forever in both directions, so it doesn't just stop at the one cycle. I hope that was helpful. Thanks.